have a presentation for you. The name of it is called this: Neutron Stars, a physicist's thoughts. Let's begin, shall we? Let us go forth into the new millennium together. In response to a question on whether it is possible to have a neutron star as the central part of the solar system that is affecting ours, and that the sun may be in a large elliptical orbit around, I am going to explain what neutron stars are and the problems behind the accepted neutron theory. There are two main theories that explain the workings of the universe, which include such things as star formation and star evolution. There is a gravitational collapse theory and the electric theory. The gravitational theory basically ignores the fact that all matter is charged and that the electrostatic force is a lot stronger than the gravitational force. The electric theory uses the electrostatic force to explain the different phenomenon we observe in the universe. Red giant, subgiant, dwarf star. Figure 1, illustration of the relative size difference between a dwarf star, a subgiant star, and a red giant star. Neutron stars were invented to explain the phenomenon of pulsars from the gravitational collapse point of view. A pulsar is a pulsating star that emits a beam of radiation. The name pulsar is short for a rotating radio star, because when the first of these stars were discovered, the radiation they were emitting were radio waves. However, since then, pulsars have been discovered that emit visible light, X-rays, and gamma radiation. Now, according to the gravitational collapse theory, a neutron star is what remains of a large star with a mass between 10 and 29 times the mass of the sun once it reaches the end of its life. The star reaches the end of its life when it runs out of fuel for thermonuclear reactions. All stars, according to this theory, start out burning hydrogen in fusion reactions, but as the star runs out of hydrogen in the core, it starts burning hydrogen in an outer spherical shell surrounding the core that is made up of helium. This process causes the star to grow in size, going through a subgiant phase and a red giant phase. Figure 1 below illustrates the relative size difference between a dwarf star, a subgiant star, and a red giant star. Our sun is a dwarf star. If the star that has at least half of the mass of our sun is supposed to be able to fuse helium in its core, while more massive stars are also able to fuse heavier elements in a spherical shells, whilst the products of the fusion reactions accumulates in the core. When the star is no longer able to have thermonuclear reactions, the core collapses, and the outer layers of the star are expelled as a cloud of gas called planetary nebulae. Whoa. If the star has a mass of at least 10 times the mass of the sun, it will have an iron core at this stage, and the process of shedding its outer layers is an explosive one, which is called a supernova. The iron core also collapses to the point that electrons and protons fuse into neutrons, and the star becomes a neutron star. This core is expected to have a mass of about 1.4 and 5 times the mass of the sun, but only have a radius of between 10 kilometers and 20 kilometers. The relative sizes of the sun, Earth, and the neutron star are illustrated in figure 2 below. The Earth is between 300 and 600 times larger than a neutron star, so that the neutron star looks like a little dot next to the Earth. The Earth is about 109 times larger than the Earth. Earth, micro-neutronoid star, sun. Look at that. Oh, so huge. So huge. Figure 2, relative size of the sun, the Earth, and a neutron star, which is just a little dot next to the Earth. This little baby. All right. If the neutron star is more massive than 5 times the mass of the star, then it's supposed to collapse further into a black hole. Wow. A neutron star can explain the regular short period with which a pulsar emits radiation, because conservation of angular momentum means that as a star's core collapses, it gets smaller. And the smaller it gets, the faster it rotates. Since a neutron star is so dense and has a small radius, it is expected to rotate very fast. Thus, if it emits a continuous beam of radiation in a certain direction relative to its surface as it rotates, the beam will be in the Earth's direction once for every rotational cycle, which causes it to seem like a pulsed signal. This is illustrated in Figure 3 below. Neutron stars have a rotational period of between 1.4 milliseconds and 30 seconds. Figure 3. Illustration of a fast-moving neutron star emitting a beam of radiation in 2 opposite directions. Spin axis, counterclockwise, beam of radiation, neutron star. The problem is that an X-ray pulsar called SAX J1808.4-3658 was discovered in 1996, that it has a period of 0.042 milliseconds. This is a problem. If we assume that this is a neutron star with a radius of 10 kilometers, we can calculate the tangential velocity of a particle on its surface from this equation. Tangential velocity equals 2 pi over capital T times lowercase r, where pi is the number 3.1416, T is the rotational period, and r is the radius of the star. Then substituting, we get, so the tangential velocity equals 2 pi over the rotational period times the radius. So 2 pi over 4.2 times 10 to the negative 5th times 10 to the 4th equals 1.5 times 10 to the 9th meters per second. Now the speed of light is 3 times 10 to the 8th meters per second. So this star's surface tangential speed is 5 times larger than the speed of light, which is not possible since nothing is supposed to go faster than the speed of light, according to Einstein's special theory of relativity. Yeah, so what do we got going on here? Looks like the physicist is breaking down even Einstein's theory of relativity. Yeah, that's kind of big in my mind, don't you think? Taking on the real big boys. Wow, another problem is that nuclei with too many neutrons are unstable, so a neutron star is supposed to be unstable and basically break up, and the neutrons decay into protons and electrons. In the electric theory for the universe, stars are formed through a Z-pinch effect. This happens because of the fact that the universe is made up of plasma, and there are currents flowing through that plasma. A current next to another current attracts each other according to Faraday's law. So they squeeze the plasma together. The electrical field at that point increases and compressed blobs of plasma appear. Then the compressed blobs of plasma form spinning electrical discharges, which glow as dim red dwarf stars, then become blazing yellow stars, and eventually become stars producing brilliant ultraviolet arcs within them. Fusion happens above the surface of the stars and not inside. Supernovae are due to galactic discharges which cause stars to blow up. This is all very interesting. Pulsars or pulsating stars can easily be explained as a charge relaxation effect. In other words, charge builds up to a point as it does in a capacitor, and then it discharges. The discharge causes a beam of radiation to be emitted. If the charge builds up at a constant rate, the discharge will happen at regular time intervals, and there is no need for the star to spin so that its surface speed is greater than the speed of light. In fact, it can spin quite slowly. So what explanation have astrophysicists come up with to explain the superfast rotating pulsar? They have gone deeper into what is theoretically possible but cannot be verifiable. No one can send a probe to a neutron star and verify that it is indeed made up of neutrons. And why not go beyond the neutrons? Why not split up the neutron into its constituent quarks and end up with a star that is made up of just one type of quark, a strange quark? The story goes like this. According to the theory of quantum chromodynamics, QCD, nucleons, protons, and neutrons are made up of three quarks, either two up quarks and one down quark, or two down quarks and one up quark, held together by the strong force and mediated by the gluon boson. The quarks also have what's called color charge. There are three color charges for quarks: red, blue, and green. When a neutron is made up of three quarks and each has a different color, the combination is color neutral. Figure 4 below illustrates what the constituent quarks for a proton and a neutron are. Figure 4, illustration of the quarks making up the proton and the neutron. The proton of two up quarks and one down quark. The proton's first up quark has a color charge of red and the other up quark has a blue color charge, whilst the down quark has a green color charge in the diagram. Proton, neutron, gluon. So with this new theory, under gravitational collapse, the star can go beyond the neutron stage and create what is called quark-gluon plasma, which then leads to the production of strange quarks from collisions in the quark-gluon plasma. The result is a star made up of strange quarks that can be less than 2 kilometers in radius, which would then mean that it does not have a surface tangential speed greater than the speed of light. In conclusion, even though my training is in theoretical particle physics and the ideas of quantum chromodynamics are attractive to me, I realize that this is not the best way to deal with observations that do not fit the current gravitational collapse theory of star formation and evolution. I think the electric theory, even though it may not be completely correct, is a much better theory. So in answer to a very good question that one of R. Wayne Steiger's subscribers asked regarding whether it is possible to have a neutron as the center of a star system, and in particular the one that is affecting our solar system, I would say that it is not a neutron star because they probably do not exist. But we could have a pulsating star as a central star, but then we would probably become aware of that unless it had a long pulsating cycle, such as weeks or months long. And if that is the case, we may get hit by increased radiation due to the discharges from this star on a cyclic basis. This is possible, but since NASA and JPL astronomers have gag orders, it may be difficult to find out the truth. We would need to observe other planets in the solar system to see if the effects of this possible discharge is cyclic and is affecting these planets on a cyclic basis. Chris Potter of Physicist Thoughts. Have a good day.